Okay, so our problem is for 133. The building slab is subjected to 4 parallel column loadings. Determine the equivalent resultant force and specify its location xy on the slab. Take F1 30 kilonewtons and F2 40 kilonewtons. Okay, so now we have 4 forces acting on the slab. X, Y, and Z axes are given. X and Y axis forms the plane of the slab. And in fact, we have 20 kilonewton load, which is on the x-axis. There exists another force which is 50 kilonewtons. It is 3 meters from x-axis and 4 meters from y-axis. Now F1 is acting at on y-axis again. It's 11 meters away from the x-axis. And there's a fourth force, F2. It is 13 meters away from the x-axis and 10 meters away from the y-axis. Certainly, they lie on a plane at which z-axis is equal to 0. Okay. So first thing that we have to do is to draw, write all the forces and position vectors in Cartesian form, of course. But I will give different numbers than the problem. So I have F1 lying on the x-axis. So this is 20 kilonewtons. F2 is 50 kilonewtons. In fact, it's here. So F3 is 40 kilonewtons. And F4 is equal to 30 kilonewtons. As a result, I have the forces in Cartesian form. So F1 is minus 20k, F2 is minus 50k, F3 is equal to minus 40k vector, and F4 is equal to minus 30k vector. Now let's write the position vectors. In fact, R1 is equal to 10I vector, R2 is equal to, in this case, so this is the position of the force vector 2. It is 4I plus 3j. Position vector of the F3, this force, it is 10I plus 13j, and position vector of F4, it is 11j. So these are my forces and their position vectors respectively. Now we will calculate the moment with respect to origin. Of course, it is R1 vector product F1, R2 vector product F2, R3 vector product F3, and R4 vector product F4. Now it is, if you write these forces, this is like this, 10I multiplied with minus 20 kj. So if I use the right hand rule and put my elbow on the x-axis, because it is I vector, and curl my fingers towards the z, it shows me negative y vector. And I have another negative sign here, so it is 200j, it's multiplication. Now 4I multiplied by 50k, again there exists a negative, it makes 200, and as a result I have 200j here. 3j multiplied by minus 50k, so again I put my elbow on the y-axis and curl my fingers towards the z-axis, and my thumb shows me the positive x-axis. As a result, 3 multiplied by 50 is 150, and I have another minus sign here, so it is minus 150I vector. Okay, here 10I multiplied by minus 50k, so it is positive 400j vector. 13I multiplied by 13J, sorry, multiplied by minus 50K, it is minus 520 I vector, and at last I have 11J, so this is R4 multiplied by the F4, 11J multiplied by minus 30K, from J to K it's positive I vector, so it is minus 330I. Now if I sum up all the X and Y components, so minus 150 here, so it is 750, so 1000 I vector minus 1000 I vector and plus 810 J vector. So this is the moment generated at point O by the forces. If I sum up the forces, I will arrive at minus 140 K vector. All the forces are downwards in negative Z direction. So now I find the moments and resultant force vector. Next thing is to calculate its position. Certainly it is rather straightforward. Let's write the position of the resultant vector by means of its coordinate. In fact, it is xi plus yj vector. So what I need to do is to multiply the vector, multiply the resultant vector with the force vector by means of vector product. So RR vector product FR will give me the moment with respect to the point O. In fact, it is xi plus yj vector product minus 140 k vector. In fact, I multiplied by k is negative, so I have another negative sign. It is 140x j vector and minus 140y I vector. Simply, this has to be equal to, this expression has to be equal to the moment generated with respect to the origin. Therefore, the coefficients or the components in the x and y directions has to be equal respectively. Therefore, we can find the y from here. So 1000 divided by 140 will give us the y value, y coordinate. It is 7.143 meters. And 800 divided by 140, so the y components has to be equal as well on either side. So 100 and 140x has to be equal to 800. As a result, 800 divided by 140 will give me 5.714 meters for the x component of the location of the resultant force.